Hello everyone. In this tutorial I'll be teaching you how to develop or how to generate a cycloidal curve. For that I'm going to take a simple sketch which I have already prepared for you. Now this is that particular sketch. Just have a look at it. There is a circle followed by a tangential line. Now here we need to know the circumference of the circle. That formula we are very much familiar. I hope you know pi d, or it could be 2 pi r distance. Okay. Now when some question asked in the examination based on cycloidal curves, diameter will be given to you or else a radius will be given to you. Accordingly calculate, and this distance from here to the end could be pi d or 2 pi r. Okay. Now here basically whenever we talk about any of the sketch related to engineering graphics, cycloidal curve that we are trying to learn, the basic thing comes in students' mind is what is a cycloidal curve, why actually it is required. Okay. Think about the application point. Does this help us anywhere in the career or anywhere in any of the processes? Now each and every sketch that you prepare will help you out at some point of time. Okay, coming to a cycloidal curve, let me define. This particular curve is traced by a point, okay, on a circle being rolled along a straight line. Let us imagine that this particular circle has to roll something like this, okay, roll around, and it should travel on this particular line without slipping on either sides. It has to travel till this particular point, till the end point. Let us imagine this as the start point, this as the end point. Okay, while traveling from the initial position to the final position, this particular point, let me call it as P, will trace number of instances. Okay, this particular P will make a mark of its own at every instance. Okay. It will come down slowly, it will come and reach the destination point. Now how many points it is going to trace, how many instances it is going to mark, that is more and more important. For example, if I'll say it is going to mark 4 instances or 4 intersection points, or else 8 intersection points, or else 12 intersection points. Okay, it all depends on how many divisions you are going to create on this particular circle. Okay, it is not that automatically it is going to create, we have to develop it at the end of the day. So here how many divisions that you are going to prepare out of this particular circle, more and more important. For example, if you want to make it into 4 divisions, so as it is moving 360 degrees, 360 divided by 4 will give you an angle. That angle need to be followed to divide the circle into number of segments. And the formula, circumference of a circle, is already known to us from the basics. So the cycloidal curve is traced by a point. Let us imagine that this is that particular point P on a circle already marked, being rolled along a straight line, nothing but a cycloidal curve. Okay, nothing but cycloid is nothing but a path or a locus on a, let us call this straight line as a directing line. For that, this is the formula. Now let me divide this particular circle into 4 parts. 4 parts. Let me call this as first part, second, third, and this becomes the 4th one, or else 0th one. Accordingly, we need to drag a tangential line of whatever the divisions you made. Accordingly, you will get the intersections. Okay. Now for example, if you try to prepare here, or if you try to divide this circle into 4 segments, you have to divide the directing line also into 4 segments. If you divide this circle into 8 segments, again this has to be divided into 8. If it is 12, this has to be divided into 12 segments accordingly. That is the thing that we do. I'll show you in another slide with clear understanding. Let me define a curve traced by a point. This is that particular point. Let me write it down here for your better understanding. A curve traced by, this is that particular point. In our case, P is the point. Okay, on a circle being rolled along a straight line. This is how we define. Okay, without slipping on either sides. A curve need to be traced by a point on a circle being rolled along a straight line. This is what the definition is. So whenever some question is given to you or some concept is explained to you, any student will think about one thing. What is that? Means what is the advantage or what is the application point of so and so X process. It is not like we are randomly picking a sketch to draw. There is some essence of drawing any of the sketches or some point. The application point of this particular cycloidal curves is, number one, I would say this is used to design a gear tooth profiles. Okay. Used to design tooth, let me erase this, gear tooth profiles. And next one may be used to design in the design of conveyors. Used in the design of conveyors. Conveyor nothing but you might have heard about conveyor belts where it will transfer the material from one point to the next. Okay, maybe in casting process, in a foundry process where conveyors are used for foundry shop where it will move the mold boxes. Okay, that in depth I'm not going to discuss now. Okay, or else you can, the third one, maybe one more example is in case of indexing devices or straight line linkages. Let me call it as straight line. These are a few examples. It is used in design of gear tooth profiles, conveyors, straight line linkages or indexing devices. These are the few applications. Okay. The basic explanation I would like to mention here is this circle, whatever the diameter given in the question or the radius given in the question, has to be divided into number of segments. It all depends on your convenience. Okay, maybe 8 parts or 12 parts. The more you divide, more smooth curve you are going to get. For example, if you divide this into few parts, maybe this is one intersection, this is the next, this is the final intersection. Okay, if I ask you to join in general, what we actually will try to do, this has to be joined again with freehand. So our effect is going to be something like this. So from here, straight line or else something like this. This is how it is going to be. The curve will never be smooth, something like this. That is just because of not having too many intersection points. So here the question is, the more you divide, more divisions will give you a smooth curve. More you divide, more smooth curve we can achieve. That is the concept. So my suggestion is always try to divide that into 12 segments. Then you are going to get a smooth curve which becomes easy for you to join too many points with your free hand. For example, if you divide into 12 segments, nearby intersections you can achieve. So when the points are nearby, it becomes very much easy and simple to join them all with freehand. You can easily manage. This is what happens. When you have the points at a certain distance, then it would definitely look like more or less like a straight line only. Okay, here you can understand I'm facing some problem, unable to reach that point properly. Again I am deleting it. So this is wrong. This is always goes right, where you can score good marks. Okay, in the next slide, let me clear this particular slide and let me take one more new slide. In this case you will understand. Just have a look at it. Just have a look at this particular slide. As I said in the beginning, you have to divide this into number of segments. Okay, for example, this is starting from this point. If I call this as P, or else let me call this as O or 0, this division is 1, this is 2, 3, 4, 5, 6 and 7. So overall it is, there are 8 divisions, parts if you talk about 1, 2, 3, 4. Similarly, have a look at the directing line, 1, 2, 3, 4, 5, 6, 7, 8. So if you divide the circle into 8 parts, divide the directing line also into 8 parts. That is a simple thing. Similarly, if you divide this into 12 parts, divide this line also into 12 parts. Okay, if this point becomes 1, similarly this becomes 1 prime, 2 prime, 3 prime, 4, 5, 6, 7. Similarly you get 8th division also. If you consider this as 8, this becomes 8 prime. So here this is the basic thing. So whatever the intersections you create here, take it vertically onto the center line. If this first center, if you call it as C, then next center going to be C1, this intersection C2, C3, C4, C5, C7, C8. This is how the intersections are going to be. So we are projecting vertically onto the central directing line. So first one is C, then accordingly C1, C2, C3 till C8 intersections we will get. Okay. Now here C1, C2, C3. Now from C1 till C8, all these acts as centers. When the radius, while the radius remains same in all the cases. Okay. Radius remains the same, means whatever the radius given to you in the question, that will remain same, but the center will keep on change. Okay. Accordingly, if for example C is the center, radius going to be, for example in the question, D is equal to 50 mm is given to you in the question, then radius becomes 25. So C1 as center, 25 as radius. First cut on the first line, which is 7-1 line. Okay, taking this as a center with your compass, cut this line. Similarly, with the same radius will remain same, no need to change the radius. C2 as center, cut the second line. C3 third line, C4 fourth line, C5 this line, because here on this line you could see third intersection as well as fifth intersection, because these two lines are, these 2 points are colliding with each other. Similarly 6-2 will come on same line, 7-1 come on same line. Accordingly you have to trace the curve. Now if these are my intersections, let me call first one as 1, P2, P3, P4, P5, P6, P7, maybe final one P8. Accordingly the curve is going to be traced something like this. Roughly I am showing you, this is how we need to do. Alright, this is what the curves look like. This curve we call it as a cycloidal curve. So the more you divide, more smooth curve we can easily achieve. Now the distance from here to this point is going to be 2 pi or else pi d. Accordingly you can calculate. Pi is nothing but pi is equal to 3.141 or else. Accordingly calculate and drag this particular line, divide that into number of segments, whatever the segments you prepare for a circle. Accordingly you are going to get the curve. Alright, for example if there is any decimal points, any in fractions, for example if you want to divide this, if this division is not of, like, you can't measure with your compass properly, if it is minute, then you know one of the method is that we have dividing a line into number of segments is one of the method. I'll show you that also. Here I'm taking 45 degrees as the angle, or else you can decrease, because any acute angle is fine. I'll go with some 30 degrees. Alright, I'll try to consider one more color for your better understanding. Here I'll try to trace a line, okay, up to infinite distance. After this, again what I try to do, with any convenient distance with the compass, by using compass, any convenient distance, maybe 10 mm or else 5 mm, what we try to do, by taking that convenient distance with the help of compass, whatever the divisions I want to create or on this particular directing line, from 8 point as the center, first intersection 5, 10, 15, 20, 25, 30, 35, 40, 45. Likewise, whatever the divisions, number of divisions you want to make, you can create 1, 2, 3, 4, 5, 6, 7, 8 are enough. Okay. So after this, what you need to do, after this simply you have to rotate. You have to place your scale, draft scale or normal scale in such a way that it should come and match with these 2 points. If this is the 8th point and last end point of pi d distance should match, accordingly draw the line. End point intersection with the end of the line, followed by take this scale, align the scale, so accordingly draw this line also. You get to get these intersections. To get, actually we are doing the task to get these intersections. Okay, again move accordingly, tighten the knob before you move and try to trace something like this. Move your drafter scale and do the task, repeat the task. Okay, you get all the parallel lines now, which will help you to get the intersections, and those intersections will be taken to the taken vertically onto the center line. Okay, that is how you are going to get the centers from C1 to C8. This is what we do. Okay, I hope you all are very much familiar with how actually we try to divide the line into number of segments. Okay, after doing this task, let me increase the size. After doing this task, we directly go to those intersections and drag the line till the center. Similarly, maybe the 2 or 3 intersections I'll try to show. Maybe here again drag the line till the center. Okay. To place C1, C2, C3 till C8. This is how we do the practice. Alright. So here again I'll just conclude here before I go on to the next slide. Fine. Divide the circle, whatever the diameter given, draw the circle first. Calculate pi d distance. Alright. Now draw a tangent line of that distance, that much distance. For example, pi is 3.14 on diameter given to you in the question is 50 mm. Then overall thing becomes 157. So the distance from here to this point is going to be 157. Now that 157 has to be divided into 8 segments, 8 parts. So whatever the division you get, if that is not possible to measure with the help of compass, then draw any acute angle, divide that into 8 divisions according to whatever the convenience you have with your compass, and join the last intersection with the end of the line and tighten the knob of the drafter. Draw the parallel lines accordingly at each and every intersections so that you get this particular intersection point. After getting the intersection point, align your drafter to the horizontal scale to the directing line, then draw the vertical lines to get the centers from C1 to C8. Accordingly, keeping C1, C2, C3 as centers, C1, C2 till C8 as centers, and radius will remain same, which is 25 mm, 50 mm is given diameter. Accordingly, cut the intersections, join them all, notate it as P1, P2, P3 till P8, join them all with the help of freehand. Okay, this is how the we try to develop. Okay, let me clear this window and I'll come up with a new one. Yes, now here you could see whatever the explanation I have given you just now. This circle got divided into 8 segments. Similarly, this horizontal got divided into 8 segments. Now here C1 as center, if I make a mark, this is the first marking, second marking, third, fourth, 5, 6 and 7. Okay. So we need to join all the intersections with the help of freehand to get the cycloidal curve. Fine. So let me trace with the help of another color which will give you a clarity. Okay, starting at this point, something like this. Okay. But you can draw freely as I am working on pen tab. Maybe it is not so accurate, but still fine. But this is how the final cycloidal curve is going to be. With all notations, with all information you need to draw this particular thing. This acts as C1. This is C, this is C, not C1. Initial one is center C. You can notate it as this is C1, C2, C3, C4, C5, C6, C7, C8. Now when you place the compass on C8 center with a radius of 25, if you cut, it should come and touch this particular 8th end point division. Alright, okay. Always C1 as center, 25 as radius. C2 as center, again 25 mm as radius. Till 8, 25 mm as radius. You are going to get the intersections, accordingly join them all. This is how the practice will go. Fine. Again, let me clear this window and come up with a new slide, which is the final slide according to me. Just have a look. The curve got traced after getting all the intersections. 50 diameter. If I calculate, I am going to get 157 is the overall distance of pi d, and that is what drawn here, followed by centers, and we have traced the curve. Complete construction has to be drawn with 2H pencil, and the curve has to be elevated, so that has to be drawn with HB pencil. Okay, this is how it is going to be. This is the final thing. Now for the same cycloidal curve, they may ask you to draw tangent and normal. Now tangent, let me write it to somewhat aside. What is the tangent? Is always denoted with TS. Normal always denoted with MN. Try to understand. I'll just with capital letters M comma N. This is the notations, and he'll specify in the question like where exactly you have to draw the tangent and normals. Maybe for example from the baseline, he may specify from the base draw tangent and normal at a distance of maybe for example 30 m. Okay, at a distance of 30 m. You should not go beyond 50 m, because if you go beyond 50 it will definitely cross this particular width. Okay, accordingly we'll try to give. If I take a simple scale, try to place the scale somewhere here. Now you could see from here 30 m has to be measured from here. If I'll say this as 10, 20, 30. Okay, if I consider this as 10 m, 10, and this is 20, this is 30. Now that 30 point, just you can drag it to right or to the left side. You get a marking over here. After getting this marking, with respect to that marking, you need to draw tangent and normal. Okay. Now as we know from the basic that the initial radius given is 25 mm. By considering that particular 25 mm, taking this as a center, cut the center line, okay, which is passing to the center of the circle. 25 as radius. For example, if I consider 25 as radius, let me erase these lines. Okay, let us consider this as the point which we got where we need to develop tangent and normal. From here 25 as radius, this point, let me call this point as maybe M, sorry not M, let us keep it as maybe. From here this as center, 25 as radius, let me cut the center line. Okay. After getting this particular center line, what you have to do is place the scale on the intersection and drag the line onto the bottom directing circle line. Fine. Now initially what we did, this radius from here to this point, the radius is R25 or whatever given to you in the question. Alright, after this take the circle, from here draw a vertical. Now rotate the circle in such a way, align your circle in such a way that the scale, align your scale or drafter horizontal scale or a vertical scale in such a way that it should touch both the points, this point as well as this point, slightly properly. Yes. Okay. After aligning, draw line up to infinite distance. After that, rotate your scale in such a way, rotate the scale in such a way that it should maintain perpendicularity with the circle which you have drawn just now. For example, with this particular line, it should make 90 degrees. Okay, accordingly place it randomly. I am placing it here and drag a line up to some infinite distance. Alright, now take the scale off. Just have a look. The line which is passing exactly from the center, have a look, it is piercing the Q point. Now this particular line is passing tangentially with respect to the curve, then we call that particular line as tangent line, which is denoted with TS. Okay, as I said in the beginning, this is denoted with TS and this is denoted with M and N, which I said earlier. Okay, this is how we develop tangent and normal. Okay, remember one thing that we have considered from the beginning. I'm talking about 25 radius and 50 diameter. For this session, imagine that the diameter is 50 mm. Don't think that this 25 is a standard value. Okay, I'm picking this 25 just because the diameter given is 50 mm. Accordingly, I'm developing the cycloidal curve. This tangent and normal is also important. They may ask you in the question. Okay, followed by at a distance of 30 mm we need tangent and normal. Now what is that 30 means? What is that 30 here? Let me take some other color for your better understanding. The 30 distance I'm calculating from here, from maybe to the directing line. This distance I'm calling it as 30, that has to be measured. So same 30, when you measure 30, this particular 30 can also be placed here. That 30 can also be placed to the other side. That is also fine. if you place it here, then you are going to get the tangent here, tangent and normal at this particular point. Anything is fine. Okay. They may ask you to measure this particular tangent and normal maybe from the directing circle or maybe from the center of the circle. Okay, that with the help of compass you can make a mark on the curve. That point acts as Q, followed by whatever the radius given in the question. You have to cut the center. Okay, now here this is C, C1, C2, C3, C4 till C8. This is how we need to draw tangent normal followed by a cycloidal curve. Okay, if you still have any queries related to this particular cycloidal curve or any other topic, any other drawing from engineering graphics, you can feel free to question. You can place your comment in the box given below. Thank you for watching.